All right, let's just dive right in. Look, if you've been following the news lately, you'd probably think this whole AI boom is just about consumer chatbots, right? Typing a prompt into a little box and getting a recipe for banana bread. But today, in this explainer, we are completely tossing those consumer apps out the window. Instead, we're going to uncover the real, hidden architecture that is actually powering this massive global AI revolution. We're talking about the bedrock layer that makes all of it literally possible. Let's hit the ground running with a crazy number: 81%. That's right, according to the latest data, NVIDIA technologies now quietly power 81% of the world's 500 fastest supercomputers. Seriously, take a second to let that sink in. We're not just talking about having a big market share in some niche industry here. We're looking at the absolute foundation of global high-performance computing. And honestly, this perfectly illustrates what's really been happening behind the scenes while we were all distracted by those consumer AI apps. NVIDIA pulled off a massive, fundamental transformation. I mean, they went from being known mostly as a gaming GPU company, the guys making your video games look incredibly realistic, into what they now call the engine of the new industrial revolution. They've essentially become the foundational infrastructure for global AI. Section 1, Context and Setup, the AI 5-layer cake. Now, to really grasp how they pulled this off, we kind of have to change how we think about AI architecture as a whole. There's this fantastic quote from our sources: AI isn't a clever app or a single model. It's essential infrastructure like electricity and the internet. And I really want us to lean into that metaphor. Think about how electricity works. You don't just have a light bulb, right? You've got power plants, transmission lines, transformers, all the wiring hidden in your walls. Well, AI has become exactly that, a baseline utility that's required to run modern civilization. So the real magic is in how this utility is structured. NVIDIA has essentially mapped out an entire ecosystem where their physical hardware flawlessly links up with their software platforms and advanced models. On the hardware side, you've got these massive systems like the GB300 GPUs. But as we know, hardware is just a heavy piece of metal without instructions. That brings us to the platforms, things like CUDA and Omniverse. And then finally, sitting right on top, you have the models themselves like Nematron and Cosmos 3. It's a completely closed-loop ecosystem. They aren't just selling you the light bulb. They're selling you the power plant, the entire grid, and the electricity flowing through it. It's the whole shebang. Moving on to Section 2, the key shift, the rise of agentic AI. We are rapidly moving past AI that just talks to us and entering the era of AI that actually does things. So what exactly is agentic AI? Well, it's AI designed to reason, plan, and act completely autonomously. We're talking about tools like Nematron 3 Ultra and Nemo Claw. Instead of you having to guide the AI step by step, hand-holding it the whole way, these systems can take a high-level goal, break it down into pieces, and execute complex workflows entirely on their own. In the industrial and scientific worlds, these highly secure, specialized agents are literally compressing weeks of intense engineering work into just a few hours. It's a total game changer. All right, Section 3, Deep Dive, Physical AI and Robotics. But the crazy part is, it doesn't stop at digital tasks. This intelligence is finally leaping out of our screens and into the real physical world. Physical AI is defined as reasoning, simulation, and action generation for the real world. Think about it. It's one thing for an AI to write a line of code. It is an entirely different beast for an AI to understand gravity, friction, and spatial awareness. But systems like NVIDIA's Cosmos 3 Omni model, combined with their Halo safety system, are actually making this a reality. They're allowing humanoid and industrial robots to understand real-world physics and operate safely right alongside human workers. There's a massive divide between these two spaces. On one hand, you have digital AI, your standard chatbots, text generators, code writers. On the other hand, you have physical AI, robotics, heavy manufacturing, and even these massive weather simulations like Earth 2. So why does this matter to us? Because physical AI demands an exponentially higher amount of computing power. You can't just train a giant physical robot by trial and error on a factory floor without, breaking a lot of expensive things. You have to train them inside these advanced, hyper-realistic simulation environments, like NVIDIA's Omniverse, long before they ever touch physical reality. Which brings us to Section 4, Real-World Impact, Powering Global Supercomputers. Let's zoom out for a second and anchor these abstract concepts to some massive, real-world deployments. Because guys, this isn't science fiction anymore, it is happening right now and at an astonishing scale. Take the Jupiter supercomputer, for example. This is Europe's very first exascale system. It's designed to tackle the absolute most complex problems humanity is facing. We're talking about advancing climate modeling, mapping the human brain, developing 6G networks. And what's running the whole thing?
It's fully powered by NVIDIA infrastructure. Jupiter is really the ultimate case study of how this physical AI infrastructure is actually being deployed for world-changing science.
Section 5. Industry Reactions Sovereign AI.
Now, as you might guess, when you have infrastructure this incredibly powerful, you get a massive global reaction. We're basically watching a worldwide compute arms race unfold right in front of us. The UK is aggressively ramping up its sovereign compute capabilities. Europe just unveiled a record 35 new AI supercomputers, and meanwhile, legacy industries are reacting just as fast. Huge companies like TSMC and Coherent are bringing AI directly into their fabs to completely reindustrialize manufacturing. The big takeaway here is that entire countries and multinational corporations are realizing they absolutely must own their intelligence infrastructure. They want to build sovereign AI rather than just renting their brainpower from someone else.
Section 6. Future Outlook. The Reindustrialization. So where is this arms race leading us? Directly to the final implication of combining massive supercomputing with agentic and physical AI. The future, plain and simple, is software-defined manufacturing and AI factories. We are shifting away from your traditional old-school data centers towards facilities designed specifically to process AI models. Just imagine fully automated AI factories orchestrating entire fleets of industrial robots and autonomous vehicles, constantly learning, simulating, and optimizing themselves in real time. It's literally an entire ecosystem of machines teaching other machines. Which leaves us with a final, rather critical thought to chew on. We started this whole explainer by comparing AI to the electrical grid, a fundamental, absolute utility for the modern world. But as we've seen, this new grid is largely being built on one single company's highly integrated 5-layer cake. So I'll leave you with this question. When AI becomes just as fundamental to our global economy as electricity, who ultimately controls the grid? Thanks so much for joining me on this explainer, and I'll catch you next time.